So the next one we're going to have a quick look at, which should be quick enough, is conjugate acid-base pairs. So basically what we're going to do is we're going to look at a basic example is the best way to explain this. If we take something like this, which is CH3COOH plus H2O. So here we've got a similar setup to what we just had with Arrhenius and Bronsted-Lowry. We have what we know is normally an acid, okay, so we know this. This is ethanoic. So this is your vinegar. This is ethanoic acid. This here then is water. And then what we're going to do is have a look and see what happens after this. Don't worry about the symbols of those arrows. We'll look at those in a later chapter. So when these two things react, in other words, when you put ethanoic acid or vinegar, you put it into water, you end up getting CH3COO single negative plus H3O positive. And this makes sense because, as we said over here, this hydrogen here is clearly going to leave, because on the right hand side in CH3COO negative, you're missing a hydrogen. So the path is this hydrogen is leaving to join on the H2O. So that means this substance here is donating. And it's donating a H+. Therefore, this is the acid. Over here in the water is accepting the H+. We know that because on the right hand side H2O clearly becomes H3O, and because it's accepting a H+, the water, that is classed as a base. So we've identified our acids and our bases. The next thing that we've got to look at is this symbol here. So this is a symbol to do with chemical equilibrium. And this basically means that the reaction runs forwards and backwards. And what that means basically is your CH3COOH and your H2O form CH3COO and H3O. And then what happens is it turns around and it starts moving from right to left. So the H3O positive and the CH3COO minus, they end up forming your CH3COOH and your H2O. Now, if that's the case, working right to left this time, we're going to try and figure out what's happening. Again, I'll stay in green here for the moment. Here, it's H3O positive. As it's H3O positive, what does it become eventually on the left-hand side? It becomes H2O. So this one here is clearly going to donate a proton. Why? Because it starts off as H3O, and on the other side it ends up becoming a H2O. This is when you're moving from right to left. So this donates a H+. Where is it donating it to? Of course, it's donating it to the molecule that's beside it. So what's the path? There. So if this is donating to H+, then this is an acid. When it's moving from right to left, of course. This substance here on the left, which is CH3COO negative, that is accepting the H+. How do we know that's accepting it? Because if we continue on this way, moving from right to left, it ends up becoming CH3COOH. So that means this is a base. The final thing that you have to do is you have to look at pairing them up. So you're going to pair the two substances that are essentially the same, but only differ by a proton. So for example, this one and this one. The only difference between the two of these is these differ by proton. You have CH3COOH on the left and you have CH3COO negative on the right. This is what's called an acid-base conjugate pair. Now, the same thing applies to the other one. So, for example, you have a base here, which is H2O, and you have an acid here, which is H3O. This also differs by H+, and if it differs by a H+, then this is also an acid-base conjugate pair. Now, in your leaving cert, you'll be asked to identify the acids, the bases, just like this. You'll be asked to not only identify the acids and the bases, you'll be asked to identify the acid-base conjugate pairs for those as well. We'll run through a few more examples of those. Sorry, the screen will probably jump around a little bit just as I pause videos and restart them again, just as I'm trying to get examples. This example is out of your Chemistry Live textbook, not the revision book. And it'll just give you an idea as to how to do them. So again, if I'm approaching this question, here's how I look at it. These two substances here, HNO3 and H2F2, are going to react. What I have to look at is the right hand side, and I look at H2NO3 and I say to myself, what's happened? Is there something on the left hand side that has changed into H2NO3? And clearly something has happened here. These have changed. The question here for us is, what way is the hydrogen moved? So if we're looking at this, the way I would look at it is HNO3 has to turn into H2NO3. In other words, this H2NO3, this one here, this has gained a hydrogen from somewhere. So where has it gained the hydrogen from? No, this is acting the maggot. The only way HNO3 can become H2NO3 is if this substance gives HNO3 a proton. So there is a donation of a proton. And it's moving from H2F2 and it's moving to HNO3. If this is the case, if this is donating it, this is the acid, because an acid is a proton donor. If HNO3 is accepting it, that means this is the base. That's all that's required in this particular reaction. You'll note that this here is one way. That means that it forms these two substances here, and it forms this, but they do not react together to go backwards, unlike the other reaction. And that's the difference between that sort of an arrow and this arrow. This arrow here means it's reversible.